Welcome everybody to the video you've been long waiting for. At long last, we're going to start looking at the subnetting that I've been promising you for quite a few videos now. So what we're going to do is we're going to start with Class C subnetting. With Class C, it's easy to start with because we're only going to be working with one octet, the fourth one. So it'll make our lives a little bit easier. But before we begin, we can do subnetting for a certain number of networks or a certain number of hosts, but we cannot guarantee both. We can only aim for one of those two things, and the other becomes whatever it's going to be. Also, you won't be able to get the exact number of addresses you want always, but you will be able to decrease the wastage of addresses or the wastage of subnets, depending on what you're after. Let's have a scenario first. So we're going to have a school in a developing country that gets given a donation of computers and networking equipment. They're going to need several subnets, none of which are going to have more than 20 host computers in them. The donors will provide the setup and support. They want to keep as many private IP networks available for the school in case of future needs. And we're going to start with the 192.168.0.0 network. So first up, let us plot our little binary decimal conversion table. I'm going to go up to 8 bits or 8 columns because that's all I need. So 1, 2, 4, 8, 16, 32, 64, and 128. Then we're going to quickly put the base numbers and their exponents above those columns. That'll be useful just now. And let's quickly jot down our starting network address of 192.168.0.0. And remind ourselves that we are looking for at least 20 hosts per subnet, although we might not get exactly 20, but we're definitely going to get closer to 20 than just leaving the subnet mask at 255.255.255.0. So, step number 1. We're going to take that default or classful subnet mask and we're going to get it written into binary. So 255.255.255.0. And we know that 255 in binary is 8 ones. So you don't have to do this conversion 3 times over. Just quickly plot out 3 octets worth of 8 ones. And 0, whether you write it once, 8 times, or 1,000,000 times, it's still 0. But I want all 32 binary bits present in the subnet mask. So now I've got that. Now, special warning, whatever is set already in the subnet mask has to stay what it is. We can't change it. So let's quickly block it out and mark it red so that we know we can't mess with it. Step number 2, we're going to start converting host bits to network bits. This is actually where we do start the subnetting properly now. And what we're going to be doing is that 4th octet that is not already set to 1s, that's what we're going to start playing with. We're going to start changing 1s to 0s. And we're going to use those formulas that we discussed in a previous video to work out what our progress looks like. So the 2 formulas that we're going to look at for now is the number of subnets, 2 to the power of n, and the number of hosts per subnet, 2 to the power of h, and whatever that equals, minus 2. Let's start with the first bit. By the way, we work from left to right, and we're going to do 1 bit at a time and see what our progress looks like. So when I convert a host bit, or a 0 in the subnet mask, to a network bit, or a new binary 1, what I have now is got a new network bit, and the remaining zeros are the host bits. So I've got 1 new network bit and I've got 7 host bits left behind. 2 to the power of 1, because of new network bits, is equal to 2 subnets. Okay, cool. And then 2 to the power of 7 minus 2, that gives me 126. Wait, huh? 2 to the power of 7 is 128, and then we minus 2, remember? If you don't remember, go check out the previous video. But that's not what we're looking for. What we want is 20 hosts per subnet. So let's try converting the next binary 0 to a binary 1 and see what happens. Now we've got 2 new network bits, or 2 to the power of 2, which is 4 new subnets. Okay, cool, but we're after the number of hosts. Let's see what that equals. So we're at 2 to the 6, because we've got 6 binary zeros left behind. And whatever that is, minus 2. So 2 to the 6 is 64, minus 2 gives me 62 hosts per subnet. We're a lot closer than previously, but I think we could still get a lot closer. So let's try a third conversion. So now I've got 3 new network bits, and I've only got 5 host bits left behind. 2 to the 3 is 8 new networks. And I've got 5 host bits left behind, so all 5 binary zeros. So that is 2 to the 5 minus 2. So it's 32 minus 2 gives me 30. Now, I know that the next step is going to be a step too far, but let me show you what you must do while you're getting used to this and getting the hang of all this. Let's go one step too far. I'm going to color that binary bit a little bit differently so that you can see, okay, cool. This is where a problem's going to come up. If you don't know the problem's coming up, don't worry, go forward and I'm going to tell you what you do then. So we've got 4 new network bits, which means 2 to the power of 4, which is 16 new subnets. And we've got 4 host bits left behind, or 4 binary zeros. 2 to the power of 4 is 16, minus 2 is 14. And that is too few hosts. We've gone too far. So what are we going to do? Is we're going to go back one step to the previous one, where we had 3 new network bits and 5 host bits left behind. Although I wanted 20 hosts per subnet, 30 is as close as I'm going to get. If I try and go one binary bit further with the subnet mask, I'm going to have too few hosts. Imagine you go to the shop and you ask for 20 loaves of bread, and the baker gives you 14. You're going to be annoyed, and you're going to want those other 6 loaves. But if you went to the shops and you asked the baker for 20 loaves of bread, and they gave you 30, you're probably not going to say anything, especially if the price tag doesn't say 30 loaves of bread. So that's what we're going to work with. 3 new network bits and 5 host bits left behind. Fantastic. Now, the next thing we're going to do is we're going to work out our new subnet mask. The first 3 octets we didn't change, so we can quickly plot those back out again. 255, 255, 255. So the 4th octet is going to look a little bit different now. So let's quickly put that in the conversion table, where we're going to have 111000000. And if we quickly do the arithmetic, that will work out to be 224. If you need to, don't feel bad about quickly doing the arithmetic. 128 plus 64 gives me 192, plus 32 gives me 224. Okay, cool. So that's what the 4th octet is going to look like now. So our whole new subnet mask looks like this: 255.255.255.224. Looks a bit weird, I know, but this is subnetting. Now, what we're going to do is we're going to try and plot these new subnets in a table, because if we don't do that, it's going to be a bit tricky to keep track of where do these new networks begin, where do they end, what's the network address in case I want to use some proper routing. You get the idea. We need to be able to keep track of this. Plus, this table is actually going to end up helping us with doing some good network documentation, which is always a best practice as a professional. So let's check it out. To do this, we're going to need the increment value. Believe me, this little formula is going to be super helpful plotting out this table. So the increment, as previously discussed in the video about the formula, is 2 to the power of I. And in this situation, the host bits and the I bits are the same. It'll be a little bit different though when we look at class B and class A, but let's worry about that when we get to those videos. We have 2 to the power of 5, which is equal to 32. Okay, cool. So that's going to be our increment. Now let's plot out a table. If you want, you could use Microsoft Excel or OpenOffice Calc, whatever preferred spreadsheet tool you're using. But I've got a nice little table I've put here in these pictures, so let's rock with it. So the first column in my table I want is the subnet number, just so that I keep track of have I done all my subnets or not. Then the next column is going to be the network address, the address that will represent that whole network and probably what will be appearing in my router's routing table once I get to the point where I start applying these subnets. Then I want to know the very first valid host address. After that, I want to know the last valid host address, and obviously everything in between are also valid host addresses as well. Then I want the broadcast address, which is the IP address used to send a message to this whole network. Next up, the subnet mask. Might as well put this in here. Then I'm going to do the CIDR notation, which I'll explain a little bit later. And finally, a very useful thing for documentation, the location or wherever we're going to be using these subnets. It's always a good idea to keep track of these things. So we know we created 8 subnets from the calculations earlier. So I'm going to put in the number of subnets 1, 2, 3, 4, 5, 6, 7, and 8. The tricky bit is the network address. So what we do is we start with what we were given, which is 192.168.0.0. Then the next network address, subnet number 2, is going to be 192.168.0. And it's that 4th octet that might be a bit weird. So what we do is we add the increment value we calculated previously to this octet that we worked in. The increment value was 32. So what I'm going to do is I'm going to put the value of 32 in there, because 0 plus 32 is 32. For the third subnet, it's going to be the previous subnet plus the increment value in the octet that we worked in. So 192.168.0.64, because 32 plus 32 is 64. For subnet number 4, it'll be 192.168.0.96. The reason is because the previous subnet was .64, and 64 plus 32 is 96. For subnet number 5, it's 192.168.0.128, because 96 plus 32 is 128. For subnet number 6, it's going to be .160. For number 7, it's .192. For number 8 is .224. And if I go one step further, it'll be .256, which, if you're thinking, wait, that's wrong. You can't have 256 with 8 binary bits. You need a 9th bit, and I know that. But I let this happen because I know if I go one subnet further than what I'm going to have, I should see a .256 somewhere in my network address. And I use that as a bit of an error checking trick so that I know I've done it right. Plus, it's also going to help me out just now when I do the broadcast addresses. But I'm going to mark it red so that we know it's wrong, but it's just helping us work some things out. So now, let's work out the broadcast address column, because this will be the next easiest thing to do. And the way you work out the broadcast address of a subnet is you look at the next network address and you subtract 1 from the octet that we worked in. So for the first network, I look at the second network address. And the second network address is .32. And if I subtract 1 from 32, that gives me 31. So that makes the broadcast address of the first subnet 192.168.0.31. If I move on to the second subnet, I look at the next subnet, which is going to be .64, and I subtract 1 from that, it gives me 63. On the third subnet, I look at the fourth subnet's network address, and I see it's 96. If I minus 1, it's 95. So that makes the third subnet's broadcast address .95. For the fourth subnet, to work out its broadcast address, I look at the fifth subnet's network address, which is .128. Minusing 1 from it gives me 127. Then, for the fifth subnet, it is going to be .159, because if I look at subnet number 6, 160 minus 1 is 159. For the sixth subnet, it is 191. For the seventh subnet, it's 223. And then, for the very last one, if I look at the wrong network address I created in red there, 192.168.0.256, and I minus 1 from that, gives me 192.168.0.255. Remember, we're always working in the fourth octet with Class C subnetting. And we're always messing with the octet that we were working with. Now that that little incorrect network address has served its purpose, let's just scratch it out. And let's start working out the useful IP addresses for giving to our hosts, be them clients, servers, printers, routers, whatever. So to work out the first valid host address for each of my subnets, I am going to look at the network address and I am going to add 1 to the octet that we were working in. So for the first network address of 192.168.0.0, I add 1, which gives me 192.168.0.1. For the second one, it's going to be 32 plus 1, which is 33. 64 plus 1 is 65. 96 plus 1 is 97. 128 plus 1 is 129. 160 plus 1 is 161. 192 plus 1 is 193. And 224 plus 1 is 225. Little tip, your first valid host addresses will always be an odd number for the octet that we work in and the octet that represents the host addresses. So that'll help you a little bit as well with error checking if you're doing this manually without a calculator. Then, for the last valid host addresses, what we're going to do is we're going to look at the broadcast address and subtract 1, because the very last valid host address is literally the address right before the broadcast. So for the first network, the broadcast address is 192.168.0.31. If I subtract 1, that's .30. For the next one, it's going to be a .63, so if I minus 1, that is .62. 95 minus 1 is 94. 127 minus 1 is 126. 159 minus 1 is 158. 191 minus 1 is 190. 223 minus 1 is 222. And 255 minus 1 is 254. Fantastic. Now, all of these 8 subnets have the same subnet mask of 255.255.255.224. So I can actually write that for every one of those rows in the column for the subnet mask. Now, the next thing we want to work out is the CIDR notation. Now, let's take a little detour and quickly explain what CIDR is. CIDR is short for classless interdomain routing. And what we're doing with it is we are counting the number of binary ones in the subnet mask. So, for instance, 255.255.255.0, if we convert that, it is 3 octets of 8 binary ones and a 4th octet of all zeros. And if we go and count that up, there are 24 binary ones in there. Now what we normally do with CIDR is we'll write that as /24, usually after the network address or IP address that fits into that class. Okay, cool. So it's sort of like a bit of shorthand for us human beings. Let's try another one. Let's try the subnet mask we just created. 255.255.255.224. We quickly plot that out. The first 3 octets are all binary ones, and then the 4th octet is 1110000. If we count that up, there's 24 binary ones in the first 3 octets, and then for the 4th octet, we've got 25, 26, 27 binary ones, or /27 if you want to write it that way. So it's doing us a favor by representing the subnet mask in a shorter manner. It's a nice shorthand, especially when you get used to thinking and working in binary. Now, for us, that's lovely, but it's also useful for the routers. The reason being, some of the routing protocols we have, like OSPF and RIP version 2 and a whole bunch of other ones, they allow us to share both the network address and the corresponding subnet mask for that network address. Now, to make that sharing of information a bit more efficient, instead of sending the 32 binary bit subnet mask like 255.255.255.0, we could send a value between 0 and 32, which only requires 6 binary bits, making it a little bit more efficient and quicker for routers to share routing information with each other. The nice thing is we've actually already done the CIDR notation, which we worked out to be /27. So I can stick /27 in every one of those rows for the column that is my CIDR notation. Lovely. And then when it becomes time for us to actually start using this table, we could just keep track of which location or part of the organization we have used the subnet in. We can say, we've used the first one for the office staff and the 2nd, 3rd, and 4th octet for classrooms 1, 2, and 3 respectively. Fantastic. So that was Class C subnetting for you. It's not too bad. It's a pretty easy way to start, but I do want to show you guys how to do Class B and Class A as well, and we're going to do those in the next 2 videos. But thank you for watching. Hope you learned something here. Hope you found this a bit easier. If you find this method a bit confusing and there's another method that you prefer, I'm cool with that. There's 1,001 ways to do subnetting, and all of them are correct. But this method I like because it works on the binary level and it really makes sure that you understand quite a bit of the nuances in the network address and the subnet mask and all that good stuff. But otherwise, again, thanks for watching, and I'll see you in the next one.